In this example, we have a continuous random variable that is defined by the function given. That is, between 0 and 1, we have 4x cubed. Elsewhere, the function's equal to 0. Now, we're asked to find the expected value of x. So we know for our expected value of x, we have x terminals of 0 and 1. We know we have a formula which says x times fx dx. Well, between 0 and 1, fx is 4x cubed. So if we go x times 4x cubed, we get 4x to the 4 between 0 and 1. So now we can anti-differentiate 4x to the power of 4. Add 1 to the index power, we get 5, and divide by that 5. So the antiderivative of 4x to the power of 4 is 4x to the power of 5 divided by 5. This integral we have to evaluate between 0 and 1. Substituting in the 1, we get 4 times 1 to the 5 on 5, minus substituting in 0, we get 4 times 0 to the 5 on 5, which will be 4/5 minus 0, which is 4/5. Part B, we're using our expected value formula. That is, the expected value of A times X plus B is equal to A times the expected value of X plus B. In this example, we have 10x minus 4. So what we do is we say A is 10, B is negative 4. So we can rewrite the expected value of 10x minus 4 to being A, which is 10, times the expected value of x, which we have just worked out, 4/5, minus 4, the value for B. So going 10 times 4/5 minus 4, we get 4. This question doesn't give us the variance. So what we're going to need to do is a calculation with the information that we already know or can readily evaluate based on what we have done in maths methods. So we're going to use the variance of x is equal to the expected value of x squared minus mu squared. Mu is the mean or expected value. We have already found that in part A of the question. We know the expected value of x is 4/5. What we need to do is find the expected value of x squared. Based on what you've done in maths methods, the expected value of x squared is x squared times 4x cubed, that is fx. So x squared times 4x cubed is 4x to the 5. Anti-differentiating 4x to the 5, we get 4x to the 6 over 6, which of course we could write as 2x to the power of 6 over 3. Substituting in the values for terminals, 1 first, minus then substituting in the 0, we will get 2/3. So our expected value of x squared is 2/3. We haven't solved the question. What we have done is given us the building blocks to work out what the variance is. Going back to our formula, variance of x is equal to the expected value of x squared minus the mean squared. The expected value of x squared we have just worked out 2/3 minus the mean squared. The mean we've worked out is 4/5. So we have 2/3 minus 4/5 squared, which is 16 on 25. Subtracting those two fractions, we get 2 on 75. So we now know what the variance is. So we're ready to do part D. Remembering for part D, the variance of AX plus B is equal to A squared times the variance of X. So A is equal to 5, B is equal to 10. So the formula, A squared times the variance of X, A was 5, so we have 5 squared times the variance of X. The variance of X we worked out in part C to be 2/75. 5 squared is 25, so 25 times 2/75 gives us 2/3.